Welcome back to Think Thrice Problem Solving. Today we're going to be solving a fun little sequence problem. So I have a sequence where the first term, x sub 0, is a, the term x sub 1 is b, and for n greater than or equal to 1, I'm going to have x sub n plus 1 is equal to x sub n plus x sub n minus 1 divided by 2, so the sum of the previous two terms. And our goal is to find the limit as n approaches infinity of x sub n. So if you'd like to give us a shot, pause the video and give it a try. Otherwise, we're going to jump straight into the solution. So the first thing we're going to look is the statement right here. So what I'm going to do is I'm actually going to write this as x sub n plus 1 is equal to 2x sub n minus x sub n plus x sub n minus 1 divided by 2. And the reason I'm writing it like this is because I would love to have this sequence where I'm looking at in terms of the previous element. So I want x sub n plus 1 to be directly related to x sub n. And I do that here, and so I can pull out that x sub n, and I'm going to have that plus x sub n minus 1 minus x sub n divided by 2. So I'm going to have my previous term plus the difference between my previous two terms divided by 2. So this is going to be pretty useful as we move forward. So I'm going to use this updated formula 1, and I'm going to look at our series here. So what I'm going to have, if I look at this, so I have obviously x sub 0 equals a, x sub 1 is equal to b. So if I'm looking at x sub 3, or x sub 2, sorry, so x sub 2 is going to be equal to the previous term, x sub 1, which is b, and then I'm going to be adding a minus b divided by 2. Okay, so b plus a minus b over 2. All right, so there's a little bit of a start. So now that I have that term, I'm now going to have my x3 term. So to calculate x3, my x3 term is going to be x sub 2 plus the difference between x sub 2 and b, but it's the x sub 1 term minus the x sub 2. So of x sub 1 minus x sub 2 over 2. And this whole thing is going to be b plus a minus b divided by 2. And then I'm going to add the difference, so that difference is negative a minus b over 2. And that whole thing is divided by 2 again. So I'm doing the difference divided by 2. All right, so I'm going to rewrite this a little bit. So I'm going to stop using all the crazy colors. And this is going to be x sub 3 is going to be b plus a minus b over 2 minus a minus b over 4. And if I was to keep doing this, and I want to do x sub n as n approaches infinity, what I'm going to end up getting is I'm going to do b, and I'll get a minus b over 2 minus a minus b over 4 plus a minus b over 8 minus a minus b over 16, and so on. So what does this look like? Let's write this in a little bit more of a mathematical form. So we're going to write this, and I'm going to have b plus, I'm going to pull out that a minus b, so a minus b times the sum from n equals 1 to infinity of, I'm going to have 1/2 to the n, and then I'm going to have this negative 1 term, so I'm going to have negative 1 times to the n plus 1, because it's going to be, initially for n equals 1, it's positive, then it's going to be negative, and it's going to be alternating series there. Okay, so I'd like to know what this thing is actually going to be going to, so this series over here. So let's rewrite this series, and let's start at n equals 0. So n equals 0, so I'm going to have 1/2 to the n plus 1, and then negative 1 technically to the n plus 2, but that's the same as if I just wrote it to the n. And I can rewrite it now one more time as the sum from n equals 0 to infinity of 1/2 times 1/2 to the n times negative 1 to the n, which finally I can write as the sum n equals 0 to infinity of 1/2 times negative 1/2 to the n. Okay, if you haven't taken a calculus class, you probably are wondering why I put it in this exact form. So this is the standard form for a geometric series. And when I'm looking at a geometric series, this term is my a term, and this is my r term. And as long as the magnitude of r is less than 1, this thing is going to sum to a over 1 minus r, which in this case is going to be 1/2 divided by 1 minus negative 1/2. All right, so what is that? So I see that that is actually going to be 1/2 divided by 3/2, which is going to be 1/3. All right, so if I go back to my expression up here, and I pull this down, I can see that now my limit as n approaches infinity of x sub n is going to be b plus a minus b, and then that's just times 1/3, which is going to end up being b plus a over 3 minus b over 3. So my final solution to my limit as n approaches infinity of x sub n is going to end up being a over 3 minus 2b divided by 3. And that is going to be my final answer. So pretty cool that we can come up with that final solution there. If you enjoyed this video, please hit that like button and subscribe. If you have an idea for a future video, leave a comment or submit a video request. And if you solve some problems on your own, think once, think twice, and if you really get stuck, think thrice.